Right here, and this question again, it's on statistics, another exam style question, exam style. All right, and this question here, it starts by saying two box and whisker diagrams are given below to represent the performance of two additional mathematics students at G2V High School by the name of Brian and Lewis for term 1, where they both had to complete 15 assignments. The box plot are given below. Well, not below, but beside in this case. So this is Brian's box plot, and this is Lewis' box plot. And it says, from the box plot, determine the following, the interquartile range for Brian and Lewis. Now, based on these two box plot, remember box plot give you what? Box plot give us maximum, it give us minimum, it give us upper quartile, it give us lower quartile, and it give us median. All right? The median is the line right here, the slash. Now, based on the graph, now you're gonna have to make estimates. So based on this box plot right here, all right, this is somewhere about 42, 43. I don't know, I'm gonna go with 43, all right? This is the lower quartile. The lower quartile, I know it's greater than 45 because it's more than halfway. So I'm gonna go with 47 for my lower quartile. Going up to here, this is the median. This look like 75, in between 70 and 80, so I'll go with 75. The upper quartile here, greater than 90, but less than 95, so I'm going with maybe 92 or 93. I'll work with 92. Bruh. And then finally, this right here, the maximum, greater than 95, I'll go with 97. All right? Good. So work out the interquartile range of scores for both Brian and Lewis. So starting with Brian, all right, the interquartile range, this is a colon to say Brian is such that the interquartile range for Brian is the upper quartile minus his lower quartile. His upper quartile is 92, his lower quartile is 47. 92 minus 47, and we know that is 45. So that's Brian's interquartile range, 45 marks. Good. Now let's do the same for Lewis. So we're going to move a little faster now because we have an idea of how to read it based on the diagrams given. So right here, the lowest look like, let's go with 49. His lower quartile here looks about a little bit less than 55. So let's go 54. The median look like 75, in between 70 and 80. The upper quartile here looks about 84. And the highest look about 91, little over the 90. Now guys, if you're doing an exam and you choose a number like 91.5 or 90.5, they're going to give you, all right? As long as they're not way off and it's an estimate. So the scale is not very vivid. So it's not, they didn't give us like a unit to represent the scale. So you're giving estimates. So you won't lose any mark. You won't be penalized. So for Lewis, it's Q3 minus Q1. His upper quartile is 84. His lower quartile is 54. So 84 minus 54, that's 30. All right. So we can see that Lewis have a lower interquartile range, and so Lewis is more consistent. Okay. Next part says the median. We need to tell them the median. So the median score for Brian, and we're just going to go back and look at the median score. The median score for Brian was 75. And the median score for Lewis is also 75. All right. Remember this line right here. These are medians. The slash them. Those are medians. All right. Nice. So those are the medians. Now it says state one advantage and one disadvantage of the box plot. One advantage of the box plot, it summarizes the data very well. One advantage, it summarizes the data very well, but one disadvantage is we are unable to determine a mean. We're unable to determine standard deviation from the box plot. All right. So number one, let's say one, it summarizes the data well by giving interquartile range, which is extremely important, and of course, the median, right? Why are these two so important? The interquartile range, remember the interquartile range is also a measure of central tendency, and the median is also, the interquartile range is a measure of spread, and the median is a measure of central tendency. So the box plot have both of them, so that's fine. All right, it summarizes data well. All right. Now, number two, big disadvantage now is when you have outliers, the box plot is very skewed. All right. Box plot is very skewed. So number one is for advantage. And number two is the disadvantage here. The disadvantage is when you have outliers, all right, the box plot doesn't take heed to when we have outliers. All right. So box plot the box plot does not, I can't bother to erase it, but the box plot does not summarize information well. So it actually does not summarize well when there are outliers, because it's going to show the skewness on it. All right, so that's one big disadvantage. All right, and you can state many more. I just said one. All right, so we don't need to get too much into it, but this is one. All right, nice. Now, the next part says, given that the sum of XB, where this represents the sum of all the scores for Brian, okay, sum of all Brian's score is 1,111. And it says that XL is 1,129, where this is the sum of all the scores for Lewis. What is the mean for Brian and Lewis? So let's start with Brian. So remember that mean is equal to, it's going to be the sum of all of Brian's score divided by N. Now, at the start of the question, they told us that they completed 15 assignments. So N is 15. So the sum of 15 scores is 1101, and we divide that by 15, and you punch that into your calculator. 1101, and you divide that by 15, and we get 73.4. So that's Brian's average, 73.4. All right, so that's Brian's mean score. Brian average at G2V in math is 73.4. Now the next part says, what is the mean for Lewis? All right, so we get 3 marks to work out Brian average. Now let's work out Lewis average. Now Lewis, all right, is gonna have his mean to be the sum of all of Lewis scores divided by the 15. That's 1129 divided by 15. And again, you just pop out a calculator, 1129, and you divide that by 15, divided by 15. And what we get is 75.3. So that's 75. This is giving right here. I type this by mistake, 73. It should be 75.3. Let's fix that. 75.3. All right, nice. So Lewis have a higher average than Brian. All right, Lewis have a higher average than Brian. All right, so you can write it down. Lewis averages 75.3. All right. Now it says, given that square B is 84,955 and XL squared is 85,302. What is the standard deviation of Lewis? So now remember, what is the formula for standard deviation? If we remember correctly, standard deviation is equal to the square root of, usually it's the sum of f times x, but in this case, we'll just write the sum of, let's say for Lewis, all right? So, or let's use L then to represent in general. So the standard deviation in general, right? In general, it's the sum of xi square minus the sum of xi all square divided by n all over n minus 1. All right, so it's the sum of xi squared minus the sum of xi square over n divided by n minus 1. Beautiful. Now we already know what n is. N is 15, and we have everything. So let's start with finding the standard deviation for, let's start with Brian. All right, so for Brian, the standard deviation for Brian is equal to the square root of the sum of xi squared is going to be xb squared. This one is for Brian. It's 84,955 minus the sum of xi squared for Lewis. All right, so for Lewis, this is Lewis score, 8. What am I talking about, Lewis? We're on to Brian. Absolutely crazy, utter rubbish. All right, so scratch that. Minus, all right, the sum of xi for Brian, and I think we said sum of xi for Brian was 1,101. So put that right there, 1,101 square. We divide that by n, which is 15, all over n minus 1. 15 minus 1 is 14. Absolutely fantastic. So that is what we have. So now we just put this into our calculator and we get the standard deviation. So you put square root of, in bracket, 84,955 minus, put another fraction here. Yeah, man, so calculator smart, everything can go in it one time. 1101 all square divided by 15, and all of that is divided by n minus 1 of 14. We punch that in the calculator, we square root it, we get 17.2. So that's the standard deviation for Brian, 17.2. All right. All right, so let's write that down. The standard deviation for Brian is equal to 17.2. All right, that's not as consistent as we would like, but you know, that can work with. That's for Brian. Let's look at Lewis now. So for Lewis, the standard deviation for Lewis is going to be the square root of, remember, it's the sum of all of Lewis scores them square minus the sum of XL all square over n all divided by n minus 1. That is given by the square root of XL square. They give us here, it is 85302. 85302 minus XL square. XL is 1129. So it's going to be 1129 all square divided by n. N is 15 over n minus 1, which is 14. So we plug that in our calculator. So I'm just going to change some of the numbers. This is 1129. And over here, this was 85302. Beautiful. So punch that in. What? That's crazy. Let's check that again. All right, just want to make sure everything is fine. Good. Is this real? 4.825. Whoa. 4.825 or 4.83. So that's the standard deviation for Lewis. Now, that is crazy. That is saying that Lewis scores deviates from the mean very little bit, 4.83. That's fantastic. All right, so Lewis is way more consistent with his scores. Okay, It says comment on which student is performing better in additional mathematics at school. So who is performing better? It's evident Lewis is performing better. Lewis is performing better. All right, Lewis is performing better. What are the reasons why he's performing better? Number one, Lewis has a higher average. He has a higher ADMAT average. Lewis average is 75, Brian average is 73. So that's number one. Lewis has a higher ADMAT average. All right, and you can put them in. So Lewis average is 75.3. Yeah, make them to say know what you're talking about. See it here, Lewis average going around here. Where did we work out average? Brian average 73.4. Lewis average 75.3. All right, so Lewis average bigger. It's greater than Brian's average of 73.4. All right, so Lewis has a higher ADMAT average. Make sure you put all of that in bracket than Brian. So Lewis is performing better. And the next reason that you can give them is that Lewis is more consistent or is consistently getting higher grades than Brian. Lewis is consistently getting better grades than Brian. How do we know that? Because the standard deviation is what we use. So you can put in other words, that is Lewis has a lower standard deviation and interquartile range. So that is why Lewis is performing better in ADMAT than Brian. All right, so that's it, lovely. All right, I really hope this would have aided us to take on more of these box plot questions. All right, so we worked out, just to summarize what we did, we used a box plot to find out interquartile range.